So here we're given this expression, and we're told that we need to find the remainder when this is divided by x minus 1. So if we use the remainder algorithm, we have some quotient function, which we don't know. But if we multiply that by the divisor, and then we add the remainder, that's our relationship. So this is really equivalent to if you were to do the actual division. Maybe an example would be if you're dividing 27 by 6, we have remainder 3. So writing it in that form would mean 27 is the divisor times the quotient plus remainder. So I'm doing it in the function form. Now, how is this helpful for finding the remainder? Because we don't know the quotient here. But you'll note that if I set x to 1, then this piece becomes 0 because x minus 1 is 0. So it doesn't matter what that quotient form is. So that becomes 0. Remainder is what it is. And I just need to replace x with 1. So all I'm doing is substituting x equal to 1 in that equation. So if I replace x with 1, this would become that value, and then I have to compute this. That one out, that one is out, and I get 0. So actually the remainder is 0. In other words, that expression is divisible by x minus 1. So the answer is C. Now I know many students will try to divide this out, which will also work, and let me do that here, but obviously this will be time consuming, or let's see if it is. So x to the 6th here, x to the 7 minus x to the 6th, I get 0. Then I bring the next term here, and then I use minus 2x cubed. Okay, maybe it's not as bad as I thought. That becomes 0 again. Then I bring x minus 1, and then I just need 1, and then I get a remainder of 0. So you'll get the same answer that way. But this approach is easier. Maybe some of you have not seen it, but you'll have to kind of think about this a little bit more. That's sort of the remainder algorithm that I used here. And another way to do this question, actually I just now see it, is by factoring. If we factor it pairwise, meaning if I pull out an x to the 6th from the first two terms, I get x minus 1. And then I pull out minus 2x cubed, and I get x minus 1. And of course, we have x minus 1. So if then I factor x minus 1, we see that this original expression is a multiple of x minus 1. Therefore, remainder would be 0. So actually, now that I think about it, my sense is that the test writers want you to think along these lines. That's how this question is structured. I don't think they're expecting you to do that, but this is helpful. I've seen this on the SAT as well, and I think I'm seeing, at least I'm applying it on the ACT here for the first time. So you have this choice, that, but I think this is how the test writers want you to think. So the answer is 0, choice C.